Okay, so with this one, let's have a read. Tavi took out a loan of $20,000 with the interest compounding quarterly. So, you know, PPY equals 4. She makes quarterly payments of $653. So there's the payment. So this is a loan. So that'd be a negative payment. That'd be a positive PV there. And then it has the graph of her data. So pretty much you've got your quarters here. This is nearly like an amortization table if you think about it. Like, well, you get similar information. Now, it's asked for effective interest rate. So effective interest rate is we need the rate per annum. So the percentage rate per annum, comma, the PPY. We know that PPY is 4, but I need to find out what the rate per annum is. So I'm going to use Finance Solver because Finance Solver, it has I equals the rate per annum. Yeah. So if I have a look, I'm going to just use two of these, the two options. So between there to there, that is 1/4. So I'm going to say N is 1. The interest rate is what I want to know. Now I can see PV, that would be what the loan she got. So she got 20,000. So I'm putting a positive 20,000. The payments they did tell me she made was 653.65. And when she does that, after 1/4, I can see that she still owes 19,527.56. And this was a quarter, so I put 4 in. So you can see up here, I end up with 3.6242. So to find the effective interest rate, I'm going to do EFF, 3.6242, comma 4, and press enter. So it's 3.67. So then this ended up being 3.6242, comma 4, and we get 3.67, which is D. Okay, with this one, so hopefully you're seeing it's the last one. So they're going to try and throw a little bit of a curveball. What I want you to really do, though, is the concepts of general math, they're not that hard, and they can't make you do something that you haven't done or that you don't know. So you really need to have that confidence and think of that to back yourself up. So what you've got to do, if you look at this, it says the recurrence relation models a perpetuity. So what we want to do is we want to think about what a perpetuity is. If you think about it, a perpetuity, we know, remember we say the PV equals the FV. What that means is the amount that's in the bank, the investment, it never changes. It stays the same. So what that means is the amount invested, this is what a perpetuity, stays the same, or stays the same. And so just the interest earned is taken away. Okay? So if you think about it, that's that D. So that's the D value, yeah? But if the perpetuity, if it always stays the same, that's so if you say PO equals A, because it stays the same, P1 also equals A. So if it was 100,000 to begin with, after 1 year, it'll still be 100,000. After 2 years, it'd still be 100,000. So it looks like that. So when they say calculate the R, so you're trying to find out in terms of their scenario, they want you to find this out. Well, let's use that formula with what we know. Because what I'm saying is, what if you did this? If I said P1 would have been found by going R times PO minus D. Now, you know that these two are the same, and they are, what letter are they? They told me Are they A? Yep. So I've got A equals R times A minus D. Okay? Now, they want you to find R. So that means they want R equals. So you just keep moving things around until, so let's move this guy over. You'd have A, what's the opposite to minusing? Plus, and that equals R times A. Now I want to move this guy, because I just want R. What's the opposite to timesing? Okay, divide by A equals R. Is that an answer? Yeah. So which one is it? B. Good. If you'd done, could have got to, so just to let you know, you could have got to this part. So you've copied out your formula and you could have done solve and comma R, and you would have ended up with the same. It would have said A plus D over A, okay?